In this video and the next few videos, we're going to be looking at a selection of statistical problems. In this video, I might just make it a big video just because this is a long thing and I can just combine it all in one. I'll see how I go about it. So we're going to look at median selection, right? How can we find the median in a set of data? Now, what is a median? Just in case we forgot, median will be the middle value in an ordered set. Right, so if the set was ordered, so 1, 3, 90, 100,000, and 200,000, this is obviously ordered in increasing order, small, bigger, 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 and this here would be our median. Simple enough, we remember this from math. Now, we want to find the median of some set. We don't really know, and it's obviously going to be unordered, right? Or else this wouldn't really be a question, right? You'd obviously just go ahead and pick the middle value. So we have this unordered set. So these values are all over the place. So 1, 3, 1,000, 20, 20,000, 7, right? This is up and down, all over the place. There's no increasing or decreasing order. What's one way that we would be 100% sure to find the median, right? Well, we know that if we were to order this, we were to sort it out into increasing order, then we can just go ahead and pick that middle value. So is that a good solution to sort it and pick the middle value? In this case, the middle value would be the ceiling of n over 2. So n over 2 position. This would work. This would absolutely work, except it's going to take a long time. It's going to take the big O of n log n to do this sorting, and then just go ahead and pick that middle value. Now, a lot of what we're studying with these algorithms is how to make them as efficient as possible, because there's a ton of ways to go about doing anything. All these tasks we want to do, we can do them in so many different ways. Lots of ways that people who have an entry-level knowledge of this stuff will be able to just go ahead and do them, like something like we just saw. I'm sure most of you guys who thought about this problem, if I gave you more time, you'd come up with something like this if I just said we need a right answer. Fortunately, a right answer will not cut it over here because this is going to take a long time. There's clearly going to be a better way to do this, because let's think about our structure over here, right? We're going to have, in that middle, we have that n over 2 position value, whatever it did correspond to. But in reality, all the values on the left and on the right, they don't need to have been sorted, right? They do not need to have been sorted. It's just a waste of resources. It's a waste of time. So we clearly saw that this is definitely not going to be the best way to go about doing it. There's going to be a more efficient algorithm, which we are going to want to find. Now, I think I will actually end up splitting this up into a few videos, but I want to go ahead, and before we get to that next video, let's just try to redefine the median, right? If we said the median is middle of unordered set, or sorry, middle of the ordered set, how could we write this in terms of an unordered set? What can we say about it in an unordered set? It's going to be the kth smallest value in an unordered set, right? So now we're no longer talking about a physical position, because you would need it to be ordered if the physical position were to mean anything at all. We don't want to care about that. It's just going to be a waste of runtime. So instead, just think about the actual numbers, right? The median will correspond to some position based on the actual values itself, right? The kth smallest position, if it were to be ordered, would be the one that winds up in the middle. And there's going to be a better way to go about doing this, which is what we're going to see. I'm going to bring one more point before we get to the next video, right? I want to talk one quick point. We're going to be using sort of a divide and, well, not sort of, we will be using a divide and conquer procedure to go about solving this the proper way, if you will, the way we're going to be end up looking. One thing we need to note is that having a bigger or more difficult problem is sometimes a better thing with the divide and conquer. We know divide and conquer will use recursion. Recursion will use induction, right? Or it will be proven with induction. So having a harder problem that gets passed through the induction will give us a better answer. It's going to be harder to prove, but we're going to get more for free in the end. And this is just something to end off this video with, to think about. think about that point, and we're going to carry this over to the next video where I'm going to show you how we could properly go about doing this process. Just because I don't want this to run on for too long, because the next video will take a while.